All right, with these three problems, we have three different functions, f of x, g of x, h of x. Look completely different, each one of them. And for each one, we're asked to find the limit as x approaches -1. And I think yours might say this, but mine doesn't here. This should be a -1. I think yours was corrected. So let's take a look. First one's the easiest one. Just a line, right? 2x minus 3. So our y-intercept is -3. So we're going to start at -3 on the y-axis. Slope is 2, so that means we can go, it's like 2 over 1. We go up 2 over 1, up 2 over 1. Do that a few times. We can go backwards too. If we're going to the left, we'd go down to left 1, down to left 1, draw a few points, and then draw our line that goes through it. Well, here we're trying to find the limit as x approaches -1 of this function. So as we get closer and closer to -1 from both sides, what's our y value getting closer and closer to? Well, as we get closer and closer to -1 from this side and from this side, what point are we getting closer to? What y value? -5. Right? This is one where if there's no hole or asymptote or anything else that we'll talk about down the road, if there's no hole in the graph, basically to figure out the limit, all we have to do is take this number and put it into the function. Right? If we take -1 and put it in for x, 2 times -1, -2, minus 3 gives us -5. Right? So this is one of those ones where it actually gets there. Even though we're talking about what's it approaching, this graph does have that point there. It could actually get there. Limit's only asking what is it approaching. Let's look at the second one. A little more complicated looking, kind of like the one we saw on the first page. But let's go ahead and simplify it, right? Because we can't really graph that, but maybe if we simplify it, we'll be able to get a graph. We can factor the top into two binomials. Bottom is just x plus 1. You may factor differently where you split up the middle term, but I kind of do it where it's guess and check. So I know the first two terms are going to multiply to give me 2x squared. So I'm going to have 2x and x. These two numbers have to multiply to give me -3. So I could have like 1 and -3, -1 and +3. And then when I take whatever this term is times x, plus this term times 2x, combine those, that gives me the middle term. Well, I'm going to cheat a little bit here and use what's right here in front of me. I'm thinking most likely in this problem, this x plus 1's got to cancel out with something up top. So I'm guessing this one's probably going to be a positive 1, which would have to make this a -3 in order for these to multiply to give us -3. But I can check just to make sure before I just assume that's the answer. -3 times x, we get -3x. 1 times 2x, we get 2x. If you add those up, we get -x. So that does work out right. And our factors cancel. So again, when those factors cancel, that means there's going to be a hole at x equals -1. So whatever makes those 0, right? And we saw that if we put -1 in here, it's going to be 0 in the denominator. So we have a hole at -1. But now we see what's left is just 2x minus 3, which is the same as this graph here. So this function is going to look just like this one, except it has a hole at -1. So we've already established -1, -5 for that point. So we're going to have a hole right here. Y-intercept at 3, slope of 2. So we can kind of draw our line here. These graphs look pretty similar with the exception of a hole. How about their limits? Are they going to be the same? Or are they going to be different? Are we approaching the same y value from both sides? So use the finger test. Put your finger, oh, what happened there? Put your finger up here, one at the bottom. As they get closer and closer to that x value, are they getting closer and closer to the same y value? Do they come together? Yeah, they do, right? At the same point as before, when y is -5. So again, with limits, destination doesn't matter. Right? The destination doesn't matter. It's the journey. Are we getting closer to the same place? I don't care if we get there or not. All right, it's not Disney World. It's just a point on the graph. It doesn't matter if we get there. Are we approaching the same thing? So in this case, yes. From both sides, we're approaching the same thing. All right, h of x. For this one, it's a piecewise function, two parts to it. First part, same as this graph here, 2x minus 3, except when x is negative 1. That just means, again, we're going to have a hole at negative 1. So if we put negative 1 in there, we get negative 5. There's that hole again at negative 1, 5. But the rest of the line is going to look basically like it did in the last function. But there's one addition to this one. It says h of x equals negative 4, which means the y value is negative 4 when x is equal to negative 1. So that means there's a point at negative 1, negative 4. So it's going to be like right here above that hole. So again, tweaks the graph a little bit. It looks a little bit different. But does it tweak the limit? Or are we approaching the same thing? All right, so as we come from the right side, the y value is getting closer and closer to negative 5. From the left side, getting closer and closer to negative 5. It doesn't matter what the point is when negative 1 is put into the function. It doesn't matter that there's a point at negative 1, 4. What are you approaching along the graph as you get closer and closer to negative 1? So the answer, again, is negative 5. So we have three different graphs here, but they're all approaching the same thing. Doesn't matter if there's a hole there or if it's filled in, or if there's a hole and it's filled in somewhere else. There's a point somewhere else. This is still going to be the same limit in this case for these three examples.